When Map Camp Serverless DevOps days first kind of started forming, Ben asked me if I would write a talk trying to explain how all three of them work together, or how they could work together, or why they should be together, or something like that. And so this talk is way too much stuff in 30 minutes. I'm going to talk quickly because that's a lot of territory to cover. But I'm going to try to talk about 3 frames, these things as frames on development and operations. Really quickly, I'm a PhD student. In many communities that I participate in, attribution is a big problem. We fail to attribute people. That's fine in professional world, but as an academic, I really ask you to give me attribution because I'm required to prove that I'm out here talking to people and that my work is spreading. So please steal everything, but please give me attribution. I'm happy to have it used. Frames. So frames and what we'll call ontological design, okay? So what is a frame? What do I mean by a frame? So a frame is kind of like, I think one of the things that people do with frames first is they kind of make it static. They don't put any time in it. So I want to do a temporal version of it. There's an idea that you have a mindset, a frame in your head that says what's probable, what's going to happen in the future. And then you have a mindset that allows you to imagine what's plausible, what could happen. And what I mean by plausible is almost like discussable. Like now we can actually talk about it with each other because we can conceive of it, right? Of course, reality is much bigger than what's plausible. So there is, inside of this, there's this idea that when we can have a discussion about what's possible, plausible versus what's probable, we can then have a discussion about what is preferable, what we want to happen, yeah? And so the range of plausibility, what we can discuss is a frame. Yeah, it's a frame. It's a frame because what's possible may not be discussable. Yeah? We may not be able to discuss what's possible. We can only discuss what we can conceive of. And so when we talk about this, give me 2 seconds. I'm sorry. I need my display to be set up correctly. I apologize. So when we kind of think about this, what we're thinking about is the idea that we want to be able to discuss as much of what's possible, but it's bounded. What we're allowed to actually do and talk about is only as much as will fit in our small, tiny human heads. So please turn mirroring off. Please play the slideshow. Okay, so a frame is roughly the idea that what we can discuss is less than what's possible in the world. Yeah, that's what I mean by a frame, and it's projected into the future. It's about what we expect to happen in the future. It's about expectations, it's about predictions, it's about assumptions about what will happen. The thing about frames is that we can kind of steer them. Yeah, we can point them in different directions to try to examine what's out there in the world, and this is what I call, or what is generally referred to as ontological design. A decision about what is ontologically valid. In other words, ontology is just a list of things that exist in the world, yeah? So when we point frames at different things, we're selecting what to pay attention to as a group, right? Of a large system that we can't pay attention to everything for. So that's what I mean by a frame really quickly. What can we talk about if we talk about DevOps? Well, DevOps is a frame of relations, yes? And what I mean by that is that I think it's interesting that the name of DevOps has in it 2 things, yeah? Developers and operators. It is about a relationship. It's not Agile. Agile has no idea of something else. It has only itself, yes? So ontologically, the name points out heterogeneity, right? So what I mean by heterogeneity is this idea that like people talk about, if you have seen this before, you know, we should all agree, we should all have the same mindset, yeah? We should all agree and have the same pictures in our head at the end of the day, and then we have consensus and we're all agreeing. DevOps is roughly the argument that because we want to explore larger amounts of what's possible, we need to expand what's plausible, but each of us are bounded in what we can think, so we need to have people who think differently than we do, or who have different skills than we do, or can conceive of or talk about different things than we talk about. Does that make sense to everybody? So this is a work by Cook, and Cook is basically saying at the top here, there are multiple mental models of what's happening in the bottom. These are artifacts, these don't change, but not everybody who uses the system can conceive of it in the same way, right? They have to have a different mental model. The really, really simple way of saying this is like most people in organizations think that they should have the same frame, but do you think that your user, the people who use your software, do they need to have the same mental model do you do? No, not at all. You expect them to have a completely different mental model. They're looking at the same artifacts, right? They're looking at, so there's different frames. There's nothing wrong with having heterogeneous models, mental models, expectations of what's going to happen. The question is about how do these things relate to each other? Yeah? What are the relationships between the mental frames? And so I think when we talk about DevOps, I think that there's a couple different frames, and I'm going to go through this quickly, but there's this really basic mental frame which says that the way that we should relate one mental model to the other mental model is just through information. So the goal here is just to like select the right information to pass back and forth between the teams, yeah? So this is the traditional ops policy wall where what you have to do is fill the form out correctly and give me the right information and approvals before I'll deploy your software, because I'm doing an information exchange, yeah? If we improve the policy wall, we will improve the system. Yes, that's one mental frame, a way of thinking about it, and it's maybe one of the things that developers, DevOps is trying to critique, right? This mental model of information, and it's about being connected is the term. I think there's this other mental model of what DevOps could look like, which I call like the naive version. It's the one I was critiquing earlier, which is like, oh, we should get everyone to have the same mental models. Like developers should think like operators, and operators should think like developers. And then once everybody thinks the same, then the problem will go away. Well, maybe the arguments will go away, but then you'll see less of the system. Yes, you'll see less of the complexity of the system because you will reduce the amount of viewpoints, yeah? So there's this last one, which is what I call the conjuncted version, yes? And a conjuncted version just means like, there's a set of development practices, and they're development practices. Operators don't need to know everything about development. There's a set of operating practices. Operators need to know those operating practices. Developers don't need to know all of them. There's a set of shared practices, yes? That is kind of what we're talking about when we talk about the frame of relation. The question that DevOps is trying to ask is, what's in the middle between that then? Why is that valuable to understand the practices that are shared, and how, by creating that boundary, not dissolving the boundary, but by effectively creating the boundary, we actually kind of create a slippage between the systems that allow them to evolve faster. And I'll get into this in a minute in a slightly different frame. There's a guy, Biffo, he's a philosopher, and he says roughly this. The idea of conjunction, that overlapping one, is that it allows for a lot of ambiguity because it's an intimate relationship. Not everything you do with your developer or with your operator needs to be this intimate relationship, but some of it does. Because the opposite of it makes some really extreme assumptions. And the extreme assumption is that you could reduce all of the relationships purely to an information set that could be interpreted in this language by a machine. So the result of this, I think, is this weird thing, and I'll go over this outcome thing really quickly. DevOps, when we talk about relations, needs to understand the difference between output and outcome. Output is the quantified, measurable resource that is produced, yeah? Something, you make something, you point at it, you can count how much of it is, you can measure it, yes? Outcome is the value your user gets from consuming it, yeah? So, like, having a bunch of bricks is not an outcome, yeah? Even having a house is not an outcome. An outcome is a healthy family living in a house where children grow up to be better educated because they have a good environment to grow up in. That's an outcome. It requires the output of bricks and houses, yes? And getting these two things separated is I think, critical, because the thing is this: the economics and decision-making frameworks of development and the economic and decision frameworks of operating want different outcomes often. And so this is where you get into a fight, yes? This is where the fights start happening. And therefore you get this weird thing, I think, that happens a lot, which is when you go to groom your backlogs together, things get really wonky, yes? This is why actually focusing only on the shared practices is so critical. You need to really quickly weed your shared backlog of anything that doesn't need to be shared, because this is gonna be a conversation that's difficult to have, yes? It's gonna be a conversation that has a lot of ambiguity in it, doesn't have a lot of clarity in it, and needs to be negotiated over and over again. So, DevOps is a negotiation between connection and conjunction, yes? It is a discussion about how we should relate to each other. I'm not saying one is better than the other. I'm just saying you need to understand that this is the two different types of relationships that you're trying to negotiate. In many, many, many organizations, you have been in the connection frame for a long time, and DevOps is asking you to move to the conjunction frame, yes? But what I'm saying is that you need to value both of these frames and understand where to apply them correctly. Does that make sense to everybody? Okay, so that's maybe the DevOps frame. I will admit to knowing just enough about serverless to be very dangerous, which I think may be true in general, but anyway, I have to talk about it, so this is my version of serverless and what I think about it. Serverless is a frame of componentization. And componentization is a very kind of specific term from a guy named Herbert Simon. And actually, the original, very early versions of componentization, frankly, were about organizational structures, not about technology. He actually took his study of organizations and applied it to technology, right? And so all sorts of object orientation and all these kinds of ideas about components, like what you think of as a component, originally were descriptions of how people organize, yeah? So this kind of socio-technical interaction is deeply rooted in the way that we think about the world. And the reason that Simon talked about this is that he was trying to defend a couple things. One of them was hierarchy, and the other one was differentiation or heterogeneity. And both of these things are often objected to in the Agile world and in other places, but here's why it's important. He tells it this way. He tells a story of two watchmakers, and he says that there's two watchmakers, and they both make watches of equal complexity. They're both equally complex. One of the watchmakers, yeah, he makes each watch by hand from scratch, basically. And every time he gets a call on the phone, he has to put the watch down, and all the parts kind of fall apart. So he's kind of got to restart each time and put the components back together again. Does that make sense to everybody? On the other hand, we got Hora, and Hora has figured out hierarchical stable subtypes or stable subcomponents. What he does is he makes little components that make up a bigger watch so that he has to get done with making a small part of the system, and then if he's interrupted, that part of the system stays stable while he's interrupted, and he can come back and just assemble the subparts into a larger part. Does that make sense to everybody? So this is, it's about focus, right? So everybody in general should have an idea of the problem of focus in software engineering, right? Like everybody talks about limiting WIP and the importance of limiting WIP and how WIP limiting helps you focus and all these ideas, right? Limiting the amount of things you're thinking about at the same time. Subcomponentry and the idea of componentization is a way of creating a mental frame that limits what you're addressing so that when you put it down, AKA you go home and go to bed and go to sleep and wake up the next morning, you come back in and the thing that you're working on isn't so big that you spend half the day loading the damn thing into your head so you can actually modify it. Does that make sense to everybody? So serverless, I think, is roughly an attempt to do this componentization of functions, yes? I'm going to try to avoid the function as service argument. I'm aware of it, but I'm going to stick with this. Ephemeral functions is what we're trying to help people get in their heads so that when they put the watch down and pick it up in the morning, they don't have to start over again. That's the frame that I believe serverless is trying to achieve. So, there's another thing about serverless, which is this. Serverless is about the difference between serverless is an ontological design decision, okay? And what I mean by ontology is literally the list of things that you can talk about, right? Serverless, in particular, is not showing on the screen anymore, but I'll read it to you. Hey, ma'am, excuse me, sorry. My screen's dead. I'm not sure. I'll try to plug and unplug. Okay, so I'm going to read it to you guys. So serverless is an ontological design decision because what it's doing is it's undesigning part of a conversation. It's removing something from the ontology. Does that make sense to everybody? What it's saying is, hey, how about what would happen to our conversations if we said you can't say server anymore? That's the question. That's the frame it's trying to get you guys to think about. What would happen to our conversations? What would we do at work if we couldn't say server anymore? Now, I think like if we want to eventually get to true utility compute and actually charge by functional usage and things like that, people have to literally stop saying server. Because if they do, the question is, well, how much does the server cost? And it's the wrong question entirely if we want to get there. Does that make sense to everybody? So it is an ontological design decision because what it is doing is it's changing what you're allowed to say, what the conversation can be. And that way, it's about reframing your conversations. It's still thinking. Okay, I will read slides to you guys. Why is this important? Well, there's another concept from Herbert Simon. It's called bounded rationality. And bounded rationality basically says this. Each of us can only fit so much stuff in our head. And not only can we only fit so much stuff in our head, but the environment around us is constantly changing. So our decision making is bounded by how much data we can load into our head in order to make a decision within a certain time frame. Yeah? And that time frame could either be driven by actual deadlines, like you have to have this done because of some regulatory issue, or it could be that the environment's changing and therefore the data you're loading into your head is rotting. It's no longer valid. So every decision is bounded, right? So we have both the concept that if you want to think of a human brain as computational power, we have a limited ability to compute and a limited ability to access data, and therefore all decisions are made within that context, yeah? So the boundedness of our decision making is one of the reasons why framing is important, because framing tells us what data to load into our heads in order to make a certain decision, yeah? So, lacking pictures, I will have to describe them to you. Many of you may or may not have seen some of Simon's FinDev stuff. I think that one of the things about serverless is also that FinDev is a lowest common denominator discussion between business and development. And what I mean by that is that, very interestingly, all the people who you work for talk about how much stuff costs. That's what they do, right? And one of the things that utility compute and serverless does is allow you to have a conversation where you know how much what you are doing costs. So now you actually can have a conversation across the tiers of the organization using a common denominator. Does that make sense? And the answer is right now, I would expect that if you're running a monolithic application, you can't really have a conversation about how much it costs because it's just a really big number, and in that number is just an infinite number of small permutations that you don't understand, and you can't actually talk about reducing it in a useful way. Does that make sense to everybody? So one of the things that I think that serverless does by exposing this concept of utility compute or the ability to price the charge of a function is that it allows people to actually start having a discussion about it. The other thing I think it does is, and one of the things I think is confusing about what I just said, so I want to be clear about it, I don't think it's an efficiency play. I don't think that it is about using economics to lower the cost of functions. What I think it is it's a way of exposing the cost of functions to a marketplace so that you increase the competition between functions that are common. Does that make sense to everybody? Like, if you actually have two functions that do roughly the same thing, then the question is which one's cheaper and can I have it? And then one of the things that will happen in that componentization and crunching down of the complexity of the function is that to make it cheaper, people will reduce the surface area of the function and make it more componentized. Does that make sense to everybody? Like it's a way of using economics to shape the market, not to just say what's the cheapest thing and how do I become more efficient. Does that make sense to everybody? Okay, so the final one about serverless is this. Complexity, all this stuff that I keep on talking about with what's possible, complexity doesn't go away. It just goes somewhere else. Does that make sense to everybody? Like, it's not that like we're reducing the complexity of function and making the complexity disappear. It's just going somewhere else. And so serverless, I would like to say, serverless is serverless, but it's network full. Yes? The complexity moves from the functions to the networking. Yeah? So I think the really interesting thing about that is, while there is a little tiff between DevOps people and serverless people, the thing that operators do well is that they operate fulfillment. And networking is a fulfillment function. It is an operations function. There is a critical need to rethink what it is that operators are going to be operating in a serverless world. And the question is, where's the data that I'm going to load into this function, and how do I connect the functions and the data together? It's a networking problem now, right? So it's not that it completely reduces the complexity, it just moves it elsewhere, and I think that's important for you guys to kind of ponder. Okay, Wardley mapping. The lack of pictures here is going to really be a bummer. Okay, so I can try a different dongle. That'd be great. Oh. Hey, Ben, do we have the flip chart anywhere? Okay, so my argument for Wardley mapping, the frame of Wardley mapping, and the thing that I think most people, probably Simon won't like me to say this, but most people don't understand about Wardley mapping is it's an ecological frame. It's about ecology. And I think the problem is that most people don't understand what that means, and then they make maps that do not reveal the ecology. They just basically take their current, like, I have a stack frame for my architecture, and I guess I just remap it onto a Wardley map, and then it tells me something, yeah? Not the goal of what we're trying to get to, yeah? So in this frame, I'm going to try to show it to you a little bit differently. Yay. That's fine with me. I would rather people here see it. I will deal with my lack of recording later. Or I'll give them the deck and they can punch it in later. Okay, great, awesome. I don't have to draw. Maybe. Okay, so let me like do some really quick reframing of some words that I like better than what Simon uses. So I'm just going to use them. First of all, up here in this corner, right, is the kind of outcomes output thing that I keep on talking about, right? It's important to notice that the cup of tea is an output. It is a material thing that gets inserted into the world in order to achieve an outcome. And I think that Simon tends to refer to the outcome here as the need often, or the user need. But I think it gets confused in some maps because I see at the very top of some maps like some user needs the cup of tea, right? It misses the outcome part, and I think that's important. So let's get that first. The second one is that like, so this is just your standard Wardley map where he's talking about tea, right? And we got the same components on the bottom here, hot water, tea, cups, blah, blah, blah. One of the things I think that would be useful for most people to think of is, hey, wait, kettles and hot water and stuff like that, they also make oatmeal. Yeah? So there's like not one need that can be provided by the things on the lower part, yes? There's multiple needs. And so there's this idea here that the stuff on the bottom is stuff that we could call a common configuration of components. And that common configuration of components we could call a regime, yeah? So you can think of AWS as a regime, because it's a common set of components that can be configured, and it's deployed frequently to solve like a really broad array of user needs. That regime stuff is not defined specifically by user needs. It's defined by a different set of economics in many ways. In the top, you get this idea that each of those users is actually basically a niche. It's like something you want to take common components to, customize them as lightly as possible so that they will use them. Does that make sense? It's like if you're thinking of ecology, this is like your species has found a very small spot that's nutrient rich, and it wants to specialize for this spot, yes? And then the idea of creating a unique configuration of components for a niche, that is what strategy is. Strategy is, hey, I've got these common components that I can use and they're available on the market and I don't want to rebuild them. I could build this very little amount of stuff in order to address this particular user need. That's a strategy. That's what strategy is, yes? So, if we look at that, I have this extra version slide just so you can see it again. What we can say is this. There is a plurality of customer needs, yes? A plurality of intended outcomes. The plurality of needs is if the plurality of needs is constrained by a set of infrastructural utilities, so kettles, you'll create an economy. Does that make sense? So if there's lots of needs for kettles, then there's an economic force on who gets to use the kettle. That's roughly what it says. And so economies are created by the competition to secure infrastructural components and capabilities to service those needs, yes? This idea is a mashup between Wardley stuff and this thing by Giels, which is also not on the screen anymore. Oh, there, maybe, kind of. And it's called the multi-level perspective. And basically it says at the top there's a landscape, and roughly that's kind of like the market forces that shape the components themselves. And then inside of the landscape live a set of regimes, a set of common configurations of components, and then there's niches, and product development and strategy are about applying those things. So the last one, which you guys can't see, is roughly this. The drawing is just the same drawing, except what I point out is that there's lots of kettles, yes? That's ecology. The fact that there's lots of is what ecology means. There's many things competing to do the same thing, yes? So when you're making a map, when you're thinking about a map and you're thinking about ecology, you're thinking about not what components I have, but what other components are out there that could provide what I have, yes? And have I made the right economic decision to, say, build my own in competition to what's available in the market? Should I adopt that thing? Blah, blah, blah. Now, this means, I think, something, to me, this ecological frame means something very specific. And the specific thing is that the thing that most people need to add to their Wardley maps is a mapping of the cost of change. Because when one understands that ecological competition is what the map is pointing out, you only get value from a market of components by being able to swap the components, yes? He who can swap the components the fastest will achieve the most value. That's, again, going to Hora again. We're increasing the componentization through a frame like serverless. We then want to be able to choose different components. So the question is about cost of change. And I like the Grady Booch quote, all architectural design is design, but not all design is architecture. Architecture represents a significant design decision that shapes a system where the significance of the decision is measured by the cost of change. So when I talk about this, somebody's screen is nice. When I talk about this, roughly you can imagine you've got a Wardley map, right? And what I think is that the cost of change is in a couple places. There's the cost of changing the internals of the component, like literally kind of like what people normally think of a tech debt. Like how much is it going to cost me to change the insides of the system? And then there's the cost of change of the relationships. Does that make sense? The ecological cost of change, the one I'm trying to point out to you right now, is all about the cost of these relationships to your business. The cost of changing those relationships to your business is the question, yeah? And so that is what I call the ecological cost of change, and it's relational, which I will point you back to that whole conversation we had about DevOps, relationality, and the cost of maintaining the internals here. That's about componentization. I'll point you back to that whole conversation we had about the way that serverless works. I have a really nice way of scoring cost of change. I can't show it to you right now. So I think this. At the end, what we're looking for, I think, or what we try to convince people to do is we have a way of scoring cost of change in like 1 through 5, and we ask people to label these relationships and the components, and then we ask a really simple question. If you want to have a different kettle, should you change the kettle, or should you change the relationships between the other things? And how is that going to work in your organization? And so the cognitive componentization or focus and the forces of simplification and generalization are the drivers of this cost of change, and the ecological cost of change, or the relational cost of change, defines these things. So, how much time do I have left? Negative, excellent. Thinking with, as opposed to answers. All of these 3 things should stop being thought of as being an answer. They should be thought of as a frame for thinking about the same things. You will be a much more effective organization if you can have discussions about serverless things, DevOps things, and Wardley Map things at the same time without reducing it to we need to do one versus the other, yes? Because they are related in the underlying principles that they're trying to achieve. Ecological optionality is a question about where can we go? Where can my company go? Increasing the resilience of your company in a VUCA marketplace, in a marketplace of volatility, and being able to reconfigure things that we have in order to meet changing needs in a marketplace. And the other question is, where can we go? The importance of our companies developing the ecosystems themselves, because increasing the optionality of marketplaces increases the number of competing components in the marketplace and increases our own optionality. Make sense to everybody? Thank you for listening to me rant.